says a piece of wood is in the shape of a square-based prism with a cylindrical hole cut out of it. If the object is dipped in paint, determine the surface area covered by the paint. We're going to talk about just the logistics behind what would be the surface area on this. If I wanted to calculate the surface area of this thing, I would have the outside, which everybody would get, right? The outside of the rectangle. But if you dip this in paint, what else would require paint on it?
Would it be the circle?
This inside circle all the way through would require paint. The outside edge of the cylinder would require paint, right? Because you're painting the inside of this thing. So when you're calculating surface area, you got the outsides of the box, but you also have the inside of the box, that hole on the inside that you have to paint. So we're going to have to remember that when we go to calculate all of our sections. We'll start with the easy ones. Okay, we'll start with the outside edges. We'll start with the sides with no holes, because that's probably easier. The sides with the no holes looks like that. That's 10 times 6. The reason I know it's 6 is because they told me it's a square prism, right, on the outside edges. And they also gave me these little lines, which means that every side's equal. So here we go, 10 times 6 times 4, because there's 4 sides. 10 times 6 times 4 gives me 240. That's the outside edges. 240, yeah. Those guys in the red. Awesome. The next spot we're going to have to do is the sides of this box. The sides of this box is right here. This time, we're going to have to subtract away the overlap because there is no equivalent circle that we would use anywhere else. So to calculate that, I'm going to go 6 times 6 because that would give me the area of that square. Then I'm going to subtract the area of that hole. That would be pi r squared. R in this case is 1.5. When you're doing this, make sure you put in your calculator properly. So remember bed mass from last unit. It might be wise to calculate it on your own in sections. So this is 6 times 6 is 36 minus 1.5 squared times pi, which is 7.06 ... And it might just be smarter to do it in pieces yourself so that your calculator doesn't screw up bed mass. Either way, you should get 28.9314, 28.9314. They're the exact same. I just want you to see that you could do it either way. I just don't want you to make a calculator error. You should get 28.9314, and it keeps going, ... That represents the square side minus the hole. What should we do with that number? Because there's one more thing we need to do.
Close them together.
Close. I think you might be saying the right thing, which is not quite how I would put it. Yeah, putting it times it by 2. The reason I times it by 2 is because this side is the exact same as the other side. Right? There's 2 sides that are squares with a hole. So if one square with a hole is 28.9314, if you times that by 2, that will give you both sides, which in this case would be 57.8628. And I'm not going to go any further than that.
So do we add the 240?
Yeah. So then if you want to figure out the outsides of just the square, you could add those two numbers together. The two numbers I'm going to underline in green. So 240 plus 57.8628. That would give you the area of the outside of the box. Add it up. You get 297.8628. Wonderful. Yeah.
I got the wrong thing.
Did you add those two numbers together?
Yeah.
Double try it. The ones I've underlined in green, the red and the blue. Yeah, definitely. Okay, that would be the outside of the box. But this thing was dipped in paint. So we have to do that inside cylinder. To calculate the area of that inside cylinder is going to be that length times the circumference. Right? The height of that cylinder times the circumference of that cylinder. The height of that cylinder is going to be 10 because the entire box is 10. So that cylinder must be 10. To calculate the circumference of the cylinder, we say it's pi times r, which is 1.5, times 2.
Wait, what is the 10?
The 10 is the height of that cylinder, how long that cylinder would be. Because the cylinder is the exact same length as the entire box.
Oh, so it's just like 2 pi r h?
Yeah.
Oh, okay.
Anyone have any questions about those numbers? If we put in our calculator, we should get that the inside is 94.24777961. And you would add that to the outside of the box. So that's adding the inside cylinder plus all the outside edges. So it'd be 94 plus 297.8628 to get your final answer of 392.11. Nailed it. That's a tricky one just to picture because people tend to mess up how to do that cylinder. It's kind of like doing the label, but the label's on the inside of the box. Hey, Drake. The one in the black box?
Yeah.
392.11. That's how you got that number? I knew it was it was a big number, so I wasn't sure. Last question, then we're done. We have a warehouse. They give you the measurements. They also drew the measurements on the picture, which is nice. An office is attached to one wall of the warehouse and measures, and then they give them a measure of that, 20 by 20 by 10. A contractor quotes to paint the exterior of the building for $2.50 for every meter square. That means $2.50 for every one area. These parts of the building are not to be painted. The 2 roofs, the office doors, the 3 loading doors, and the 4 windows on the office. How much would it cost to paint the building? So, if you think about this, he's just painting the outside of the outside of the warehouse. They just kind of put it in a fancy way. If you're not painting the roof, then you're painting the sides. And that's what this first part said. You're not painting the 2 roofs. So it means you're doing sides only. So if I'm looking at this building, I'm doing sides only. And you're not doing doors, and you're not doing windows. So the way that we would want to tackle this, and those little windows are kind of tiny. You probably can't even see them when you're drawing. The way we want to tackle this is do all the outside edges and subtract away what you wouldn't use. So we'll start with the big walls of the big building. If I wanted to calculate this big one on the left, which I'm going to color in red, that would be length times width. So it is 20 meters tall. I know that because it told me over here. And across this length would be 30. Again, they've told me that info just on the other side of the picture. Yes. That's good. I wasn't sure. So to do that side wall would be 20 times 30. And then I'm going to times by 2. Why would I times by 2? Because there's two sidewalls, right? One on the left, one on the right. So I'm going to go 20 times 30 times 2. That gives me 1,200. That's the side left, side right. Now I'm going to do, yeah, you need to stop. Now I'm going to do front and back. The front and back, I'm going to pretend, I'm not going to worry about the door. I'm not going to worry about the windows. I'm not going to worry about any of that stuff. I'm going to do that all at the end. So if I want to do the front and I pretend I don't worry about the door, this would be the front right here, which would be length times width, the length being 60, the width being the height, which is 20. 60 times 20, and then you get times by 2 because there's a front and there's a back. You throw that in your calculator, and you get 2,400. Now, when I was doing the front and the back of the big building, that also had overlap when the two buildings were against each other, correct? So I technically should have subtracted away that overlap, but I don't need to subtract that overlap because I'm just going to not add the front of the smaller building. I'm going to say that front of the smaller building counts as that overlap. Awesome. Now I'm going to do, yeah, for sure. Now I'm going to do the sides of the little building. The side of the little building would be 20 times whatever the height is, which I believe is 10. I've kind of colored it in blue there, but I believe the height of that little building is 10. If you're not sure, it says in the question, yeah, it's by 10. So you go 20 times 10 times 2, because there's two sides to that little building, which I believe is 400. If you add all those numbers together, all those totals, that will give you a total of 5,000, right on the dot? 4,000 right on the dot.
It is 4,000.
It is 4,000?
Yeah.
Yeah, it's 4,000. Yeah. 4,000 would be all the sides, but that's covering, that's painting the windows, that's painting the doors, like that's painting all that extra stuff that we definitely shouldn't be painting. That's just the sides. In this question, we don't.
No, you could.
You could, just on this question. So now we need to do 4,000, and we need to subtract the doors and subtract the windows.
The windows are tiny. How do you know?
And they told you in the question. So if you look, it says the office door with an area of 2. That means I got 4,000 minus 2.
No, there's only one office.
The other one's a loading door.
But it's also 2 meters squared.
There's 3 loading.
Yeah, so when we were doing our calculations, like that's 4,000 meters squared. So that would be 4,000 meters squared minus 2 meters squared. And my units are just kind of canceling each other out. And then I need to subtract the loading doors. There's 3 of them, so 3. That measure 10 by 15. So 3 times 10 times 15. And then I need to subtract the windows. There's 4 of them, so 4. And each one has an area of 1. 4 times 1. I would do bed mass on my own. So I would calculate all these to go 4,000 minus 2 minus 450 minus 4. And that would give me my grand total of the area that needs to be painted, which would be 3,544. So I did the area of all the sides. Then I went back and I read the question again and I subtracted my man door, my loading doors, and all my windows. Brennan.
Don't you have to touch by 2.5? It's asking how much it costs.
Oh yeah, that's just the area. Thank you. 3,544. That's the total area. And sorry, that didn't answer the question because the question talked about the guy's quote, right, to paint the building. So 3,544, that's the area he needs to paint. He quoted that he would do it for $250 for every meter squared. So if you want to figure out the total amount that it would cost to paint your building, you would do your total area and you would times it by 250. And that would tell you how much it costs to paint the building. 8860. Calculated the area of all the outsides, subtracted the doors and the windows, multiplied it by 250 because that's how much it costs for every single meter that I want to paint. Wonderful. Before you all run